Hi, this is Joel Levitt speaking. I want to introduce to you a new 3-day course called Prescriptive Maintenance. The goals of this short introduction, first of all, I want to demystify all this new tech that's come out. I want to show how it fits in with traditional maintenance. I want to show you case studies on how people have gotten gains. And we'll start with an abbreviated agenda. The goal of all this stuff is to get the best business decision possible for the company. And we'll try to give the value proposition, where the value comes from, defining prescriptive maintenance, and showing you a block diagram of how all the pieces interact with each other. Now, prescriptive maintenance and all this tech that goes with it is a small part of a much bigger picture, and will show where this stuff, the tech and the software, fit into traditional maintenance so you can get the benefit. Also, we'll look at what changes in the workflow, in basic maintenance, work orders, your CMMS, and then we'll get into inspection technologies like drone, PDM. We'll look at augmented reality, where screen and mask to help them identify what is going on and what they're looking at. And virtual reality, which is the best training method we have, short of actually doing the job, and in some cases it's better than doing the job for training. We want to talk about how to use RCM. RCM, Reliability Centered Maintenance, is the most rigorous method of deciding maintenance strategy, and we can use it to help pick sensors, so we're looking at the right failure modes. Feeding all this sensor data feeds into create a big data or a big database with all this information in huge amounts of storage. So we're looking at what is this, how is it unique, how can we use it, and we create what's called the asset halo. In other words, all the information in one place linked, so we can see what happened, when, what was going on in other different areas. It's very comprehensively. And we can then build a digital twin where the computer simulates the machine and allows you to test ideas on the simulation before you try them on the machine. Analytics is where we take this big data, this huge database, and decide what to look at to see what's going on, to see what's going to go on, and to see what we should do about it. And we'll look at the different types and examples of analytics. Analytics feeds into what are called algorithms, and algorithms are the backbone of artificial intelligence and machine learning. So we'll look at what those things do and how they work. What's missing from all this? So we'll talk a little bit about what's missing, and finally build a roadmap. Now, this is not a computer science course. This is a course for maintenance people, maintenance professionals wanting to learn really what this stuff is and how to use it. So I'm Joel Levitt. I've been in the field for 25 or 30 years. I was past director of international projects for lifecycle engineering and past director of reliability projects at Reliability Web. I've worked with big organizations, mostly some medium-sized organizations, worldwide, 27 countries in 500 sessions. You could say my hobby is writing books about maintenance. So I've written 11 books about maintenance, have a couple coming out. Proud of that effort. And in my spare time, you can see I do a little woodworking. Now, the goal of this tech is getting to the best business decision in real time for the whole company. So it's the best decision for the whole company, not just for finance, not just for operations, but for the whole company. We have to decide, and in maintenance this is the decision, if there's an intervention and what intervention and when should we do it. So we look at the condition of the asset, its failure probability and risk, looking at what is the consequence of the failure. Is there really dire consequences? Is it minor, or is it significant? What are the consequences? And then we have the data stream coming in from the asset itself. We take into account production and maintenance. We take into account what parts we have, the lead time of the parts we don't have, financial needs, and maintenance costs. So the way I want to introduce you to this class is I want to give you, reproduce one of the discussions that we'll have in the way we have it, and in even some of the slides will be similar. So you get a sense of what it is we're going to be talking about. And the question is, why big data analytics and machine learning are important but not sufficient for world-class maintenance. So it's also kind of an interesting question. Now, traditionally, we would measure the maturity of your effort by looking at the ratios of reactive maintenance to planned and preventive maintenance to predictive maintenance, because as you know, as you get more proactive, the cost of the maintenance incident gets lower. That's offset somewhat by the cost of the inspections and the proactive activity. But in general, it's the more proactive you are, the smaller the repairs, the higher the safety, the less impact on quality. So this is the traditional model that we've used for years. We've added something to this in the last few years. We've added what's called precision maintenance. Now, what precision maintenance is doing all the tasks, whether they're repairs or installation, do them exactly the way they were designed to be done. So bolts get torqued to spec, lubricants are, the right lubricant is used in the right amount. So that's precision. And the thing about precision is, more so than any other change, is that once you start doing it, fewer things will happen. In other words, this particular case that we're talking about, the failure was due to a misalignment detected by vibration analysis, as you can see in the oval on the left. So that's the point where misalignment was detected. But in precision maintenance, that misalignment would not have occurred in the first place, because we would have aligned it using the best techniques and the highest specs appropriate for that asset. So instead of having this cascade of failure, this PF curve we call it, what we would have is another nice day at the maintenance shop, where we wouldn't have these catastrophic events, because we're putting things, anything we do is done in a precision way. So that the event never happens. So you can see the point where the misalignment, we back up to when the installation was done, and then we would have done it correctly. So precision installation is the beginning. Actually, precision machine building is the beginning. Precision alignment, precision balancing, assembly, bolting, lubrication, precision cleaning, proper quality spares, housekeeping, and of course, precision operation. Now, with all this tech, we've added something else. We've added what's called prescriptive predictive maintenance, where we take all the predictive maintenance tech and feed it into a cognitive process that gives us prescriptions or work orders to fix things before they fail. So we've automated some of the predictive maintenance functions. Now, you wouldn't go very far wrong if you think of it like having a really little experienced maintenance person inside the computer that never sleeps, that always wants to look at maintenance data, reviews the data, and when they find a problem, they write a work order. So that's kind of what we're looking at. With prescriptive maintenance, there's always a recommendation. The prescription is the difference. Now, many of you use infrared, and you'll come across a scan like this. And the difference between prescriptive maintenance and predictive maintenance is that in predictive maintenance, a human will look at this picture and determine what they think the problem is and what the solution is. So they'll write a work order, and the steps, would be to disassemble and, note any burnt parts, replace anything that needs to be replaced, clean everything, reassemble it, torque it to a value, and then rescan it. So a human has to do that, so the human has to have time to do that. They have to be, fully fed and not fatigued, and it can't sit in an inbox. It has to be dealt with. So that's predictive maintenance. In prescriptive maintenance, the machine, the artificially intelligent computer system, would use all the data coming in to decide that this thing needs to be worked on and issue the appropriate work order with the appropriate work instructions. Now, if you've been around, that is really cool. And just like everything in today's day and age, it takes some work to get there. I'm sure you've read and heard about world-class maintenance. This is a concept, and I want, it's not like something that's really there. It's not real, but using it can have real benefits, because what happens is it creates an opening for action and causes your company to expand and develop past what maybe they thought was possible before. And just like all this kind of stuff, if somebody comes to you and gives you a guarantee they'll get you to world-class maintenance, there's no question you're going for a ride, okay, if you get my drift here. I call this an aspirational domain. This is where everything is clicking together. And few or no people are clicking on all these cylinders. Everything from all the tech, the sensors and big data analytics, to the design for reliability, to the defect elimination, precision, leadership, root cause analysis. This is where we're really talking about, where everybody works together to get this done. So the question that I asked was, why big data analytics and machine learning are important but not sufficient for world-class maintenance? And here's the reason. The tech is important. Having these wireless sensors all over the place for like $100 or less a piece is awesome. And having advanced analytics, having really, really, really smart people think up analyses and then apply that to all the data is really cool. But you have to put that into a culture that can really use it. So things like precision, everything, precision maintenance, precision operations, designed for reliability so that the equipment is really, really robust for its use. Ongoing, continuous defect elimination. You've got a pool of defects out there, and your job is to remove defects from that pool faster than they're going into the pool. Everybody is a reliability leader in their area. So I don't care what your job title is, you're a leader in that area. We want to also have good risk management, maintenance prevention, root cause analysis, and mistake proofing or poka-yoke. So that's the world-class maintenance. That's the culture of world-class maintenance. And the technology enables us to do things that we couldn't easily do before. So I really want to thank you for listening to this prescriptive maintenance introduction. And I'd like to extend an invitation to you to join us for this 3-day class. And I promise you will get insights into the current wave of tech that's going on in maintenance now. So thank you very much.